So every packet which contains healthcare information has to be prioritized. So we have to make sure that there is enough network availability and there is reliability in the network, that whatever is the data generated is being transmitted. Right? End-to-end latency comes into picture more so from remote healthcare perspective. You must have seen these, I think, beginning of this year, there was this first robotic surgery done somewhere in Europe, where a doctor operated somebody remotely, right? And in that context, the end-to-end latency becomes important, because essentially, when you are doing surgery or when a doctor is doing surgery, real time they have to operate and decide, okay, they're going to cut certain amount of tissue, how much to cut? Have I cut too much? Maybe I should put some sutures, right? So these kind of decisions have to be done within a second, because especially for complicated surgeries like heart or liver, spleen, right? It can result in catastrophic damage to the patient. So if we are doing this, if a doctor is doing this remotely and there is, let's say, few second latency, then by the time doctor realizes something has happened, it's already a irreversible damage. So for any such application within the context, broader context of healthcare 4.0, the latency has to be minimum. It has to be within milliseconds, right? The current 4G definitely does not support within millisecond latency. 5G claims up to millisecond latency, but the current deployment that we have for 5G, for example, in the Indian context, are not millimeter wave deployment. They are all NR, non-standalone deployments. Essentially means the current 5G also, we have one user at least to cross verify. It doesn't have millisecond level latency. It has much higher